Hey everyone from J4K. Thank you for being here. Thank you for your time. I hope you are enjoying the whole event. And now it's my time to share something with you. And I will already split to my slides here. Let's talk about how to build scalable and resilient microservice using not only Java, but Java with Quarkus and MicroProfile. Okay, and I don't know if you have attended to one of my sessions, but I really love to be very practical. So that's what I'm going to do today. So this is my second and only slide, almost only slide here today, just to tell you what I'm about to do. So I will build an application using, of course, a microservice approach with some REST client, health check, metrics, reactive. I will add some Mutiny and Kafka, and everything working with containers and Kubernetes. And that's my only slide because now it's code time. So let's build some code here today, okay? Not yet this website, just to make sure that I have my, yes, this is. Okay, guys, so we'll build an application, of course, using Quarkus, as I just told you. And there are two ways of building a Quarkus application. One way is using this website here, this beautiful website, where, let me just refresh. Okay, we are here. I can, for example, if I'm using Maven, I can just use Incon, other Moraes, code with Quarkus, I can use, for example, tutorial, and I can use Maven or Gradle, no matter. And here I will pick the extensions that I would like to use. And there are dozens of extensions. I believe that we have easy more than 100, maybe even more. Okay, never counted, but that's fine. Okay, guys, but I'm not in, okay, and if I use this website here, for example, I can just click the extension that I would like to use and use the download here, and boom, I have my project ready. This is one way. I will use the other way, and I call it the fun way. And the fun way is using the terminal. So I will build my Quarkus application using my terminal here. This, okay, doing pretty much the same, but using the terminal, okay? Let's move to my the application folder. I will open my VS Code because I like it, okay? And I will use VS Code here today. I'm using two plugins from VS Code, the Java plugin and the Quarkus plugin. Both plugins made by Red Hat, and they are very lightweight, so I really enjoy using them. I will remove my tests. Don't do that at home, okay? Because you should not remove the tests from your code, but just in order to help us to be faster here today, okay? So this is the structure of my project. Here we have our Docker files, if you're gonna use it. We have one REST endpoint. I have also here the resources, the configuration files, and etc. Okay, so I will use another feature from Quarkus, developer mode. What is that? It will compile my project and will start my application. And as I will be here adding code and creating stuff. This will be live available for me. So this gives me a lot of productivity. Okay, so here, 1.6 seconds to start this application. All right. Okay, guys, just before moving forward, just to let you know who I am. My name is Elder Moraes. I work at Red Hat. I'm Brazilian, based in São Paulo, and I'm a developer advocate here. And I'm the head of Red Hat developers in Latin America. So all countries that we have here in Latin America, I'm trying to help. I'm not trying, I'm really helping the developers down here to work with Red Hat technologies and approaches and Java and microservices and Kubernetes and stuff. Okay, so here I am, but it doesn't matter who I am. It does only matter what you will learn today. Okay. All right, guys, so today I will follow one tutorial that we have for Quarkus. So you will see me copying a lot of code here just to make it faster, okay? Because this tutorial would take like 3 hours to do, really following the pace. We don't have 3 hours, we only have 30 minutes. But I will give you the whole picture of what I'm doing, what's going on, in order to you be aware what's happening here. Okay, so I have my application running. Let me try to access this application to check if it's working. Okay, it's working. So we are good to go. What I'm gonna do here right now is to create a CRUD. Okay, so a small application to deal with fruits. Okay, this application will manage some fruits. Quarkus works with extensions. So everything that I need to add here, I will add some extension. Okay, so I will add some extensions here to deal with JSONB, with data access, to database access as well. Okay, so let's go. I will add some properties. Let me go here. Okay, always, I will open my application properties, and I will create some properties for access data. And let's start creating our application. Okay, so I told you I will work with fruits. So let's create a fruit entity, fruit.java. Okay, so here I have my fruit. Okay, it has a name and a season. Okay, all right. And now I will create a REST endpoint. Let's create it here. It's a fruit resource.java. And this one is a very simple REST endpoint that will just use our entity. We'll list here a fruits list, and just using the entity to list all the data on our database. Okay, it's not exactly a database, but you got. Okay, let's access and see. I didn't reload this application. Okay, I would just try to access some method that didn't exist when I first started this application. Okay, so let's just try to access. Okay, so here in 1.9 seconds, Quarkus replaced everything on my application. Now I have the access to my new endpoint. Of course, it's empty because I don't have any data. And I don't have any method to add a new data. So let's create this method. Okay, now I have here new fruit. Okay, it's a post method, transactional. Will consume, produce, and create a new fruit on my database. So let's just call this new method. It's a post method. Okay, so that didn't exist so far. Now we have a replacement in 600 milliseconds. And now I added a banana to my database. And now I have a banana on my database. Okay. But I'm a developer and I need more data to work. Okay, so let's add more data to my project here. So I will create a new file. It's an import.sql. And I will make a lot of inserts on my database. And let's just, here, I will call again the same. Now I have a lot of data on my database. Okay, so even my other files, not only the classes, but here an SQL file was also hot replaced on my project. Okay. Okay, now I have a lot of data. I will add, because you see here I'm using, let me just come back here. I'm using a default method from my entity, but now I would like to add some custom method on this entity. So I will create this one. It's defined by season. So I will pass a season, and okay, so can have a filter for the season. Good. So let me also update my endpoint. So I can now use this new method. So if I have a season being passed as a parameter here, I will, of course, filter by season. If not, I will keep listing all the items from my database. So let's try it. I will call using a new filter, season. So now I have in 500, almost 600 millisecond, my application replaced it. So this gives me a really good productivity, okay? So now I have all my fruits that came from season, not from summer. Okay, guys, so what else I'm gonna do here? If I would, for example, if you are used to work with repository and not accessing directly an entity. So yes, you can do that using Quarkus. So I will add a fruit repository here, and I will add this repository here. Okay, so it's pretty much the same. Okay, but now I have a Panache repository and a fruit repository with the same method here, and just update our resource to use the new method. Okay, so I'm of course registering here the repository and using it here. And if I call again our curl using summer, so the result is pretty much the same. Okay, guys, so right now I will do one stuff that we are, of course, at J4K, so we love Kubernetes here, and I would like to have this application running on my Kubernetes. And let me check if I am connected to my Kubernetes. So cluster info, it should be connected. Okay, so now, yes, we are connected. I will do one stuff here. I would like to have this application running on Kubernetes, right? And if you ever worked with Kubernetes, you know that working with YAML files is not exactly easy, and to maintain YAML files is not exactly easy as well. But Quarkus has two extensions that will make your life very, very easy. One is Quarkus Kubernetes, and the other one is Quarkus Container Image Gib. What they are going to do right now with my project, the Container Image Gib extension will let me create and push a container image without need to build a Docker file. Okay, I showed you that Docker file that it's available in my project, but this extension doesn't need to use that Docker files to create a container image. And the Quarkus Kubernetes will let me deploy this application on my Quarkus cluster without need to build any YAMLs at all. Okay, so what am I going to do here? I have my application. Okay, so I will just do not just do. I need to create some properties. So let me copy my project properties here. These properties here will stay here. Okay. So I will connect to my account on Dockerfile. This is the name of my application. This is the tag. I will create a load balancer on my Kubernetes cluster. And this is how to deal with my certification. Don't worry about it. So mvn clean package -d Quarkus Kubernetes deploy equals true. If I didn't mess up here, it will compile my project, package my project, create a container image, push this container image, and got my YAML files for Kubernetes and do the deployment on my Kubernetes cluster. I think it's working, okay? Sometimes I forget to do something, but today I believe that's really working right now, okay? This makes your life very, very easy because to do all this life cycle, since creating the project and do all the tests while you are developing, and then do the pushing to build an image, to push the image, and then to make deployment on Kubernetes is not something really so easy, so fast. But right now, just with one line of code, I have, for example, let me show you. I have here ls target Kubernetes YAML, not ls. I will show you the code. Okay. This YAML file was created by the packaging process. I didn't create these files. Okay, so I have here the whole YAML file with the service, the name of application, the ports, everything, the deployment, the amount of rep, because of course you could customize everything, but this is the full way of doing it. Okay, and in a few minutes I will add a health check probes to this application. And once I package this application again, the REST endpoints for this health check will be also added to this file. Okay, so this will really make your life easy. Let me check here if I have my pods working. Get pods, yes, 76 seconds. So this is the pod I just created. So I should also have a service. Yes, I have the service here, 84 seconds. Let's try to call this service. Sometimes it took 1 or 2 minutes, but sometimes I'm lucky guy. Yes, today I'm a lucky guy. So it's already available. So I have my project that I just created and it is available on the Kubernetes. Okay, so let's move forward. I'm sorry. Now, okay, I have my fruits here working and everything. It's great, but I would like to add some data to this application. So this is my microservice, and I want this microservice communicating with other microservices, okay? And I know there is a service available somewhere called FruitVice that has some other data about fruits, okay? So I will connect my application to this other application in the cloud in order to have more data about my fruits. And for doing this, I will create a REST client. Okay, so I will, now I need to create a Pojo. It's not something really fun, okay? But I need to do it in order to make it work, but it will be fast because I have everything ready here just to show you how you should do that. Okay, now I will create my REST client, FruitVice, and this is where we will communicate with our service, okay? So this is the method that we are going to use. Here, I'm pretty much using MicroProfile, okay? Register REST client, the path here. So everything here, you can even see here, MicroProfile package. So I'm pretty much using it, okay? And of course, we need the URL to access this service. So I will add the URL here. You can check out later on fruitvice.com. Okay, so they have some data about fruits. Now I just need to create one detail, and then we are good to use our REST client. Okay, so that this guy here. And then, okay, now we can update our fruit resource to use our FruitVice service. Okay, so we registered our REST client there. Here we just inject it, and here we have using it to. So basically, I have my fruits on my local database, and I will bring some more data from this other service from FruitVice. Okay, so let's invoke the service. Okay, I will invoke here. And 1.7 seconds. Okay, so now we have our fruits name, season, but we have more data. We have carbohydrates and we have calories. Okay, so we are combining here two different servers, two microservices, let's say, to bring the same data to the end user. All right, good. So let's go forward. We are talking here about microservices working in a resilient way, and I will add some fault tolerance features to this application. So I will add the fault tolerance API from MicroProfile as well. And I will basically just one example of fault tolerance. There are a lot of available in this API, okay? So, but I will just create one of them, two of them, okay? Just to make it fun. Let's go to our FruitVice service, okay? Where we defined our interface. So here, basically, I created a retry feature. So, okay, so imagine that we don't have access to the service. You don't need to give an error in the first try, okay? You can, for example, in this way, try 3 times, and then if it's still not working, you can then give an error. Okay, I will delay 1 second on each try, and let's, in order to force the error, I will just make whatever URL here just to make sure it will really not work. Okay, we will call again. Okay, summer. Okay, so now it will not work. And of course, it's a error that you should not send to your users, but let's improve it. I will right now to add a fallback class to this application in order to make something more smart to the way of dealing with this error. So I keep my retry here, 1 second. And if we got the 3 errors, I will use my fallback class. Okay, so I will call this class, and this class will just return a empty return of FruitVice. Okay, so let's try again. Okay, let's wait. So it will just 3 to 5 seconds, and then okay. So as we really didn't got the access to this service, they are all empty. Okay, it's just an example. Of course, you could deal with the error in the way that should do best for your reality. Okay, let me change this to fruitvice.com. And right now, what I'm gonna do, I will add a health check to this application by adding a extension. Okay, so health check, small array health check, is also came from MicroProfile. And the one interesting thing about the health check extension, you see, I just added it to my project. And if I go here to my browser and call this endpoint, it's available, okay? Because it's default from the implementation. Once you have the extension added to your project, you already have this endpoint for free. But of course, you can make some customizations, and I will create 2 probes here. One liveness probe. What is a liveness probe? It's a probe where you say that if your application is live or not, okay? So what's the difference in the end of the day? Just to let you know, here I'm implementing a health check interface, creating a class liveness probe, and using this annotation, liveness, okay? So if my application is live, it will just say, you know, I'm alive. It's not live. If you are not able to call this probe, it's because the application is not live. So basically, Kubernetes will kill the pod and create another one. And let's just create the readiness probe. What's the difference between them? Their liveness probe, you say, look, I'm live, so I'm here. And the readiness probe, you say, well, for example, I'm here, but I'm not ready. or I'm here and I'm ready. Imagine that your application is trying to access some database, for example. So your application can say, look, I'm live, but this resource that I'm trying to access is not available, so I'm not ready. The difference that in the first case, if your application is not live, Kubernetes will kill the pod and create another one. If your application is live, but it's not ready, Kubernetes will just wait to be ready, okay? Now I have my 2 probes customized here. If I call again this endpoint, okay, now I have the return of each probe available here. Okay, I just have more 5 minutes. 5 minutes? Yeah, 5 minutes. So I will create, let me check here. Okay, I will show just one example of Reactive, okay? So the API that Quarkus uses to implement Reactive is Mutiny. So I will just move here from fruits and let's deal with beer. Okay, so we have another online service that talk about manage some beer list, and I will use it here. So I will create a beer kind of entity. It's not really an entity, okay, but just to deal with the return of the service. I will create, of course, another REST client. So let me jump here. Now we'll move a little bit faster just to show you this last example. So I have this REST client also configured. I will add the URL of this other service, this one. And let's just create our beer resource. And this is a resource because this service, this beer service that I'm accessing here, it will return the data not in a synchronized way, okay? We are not using the synchronized way. So we are here using the mute to be reactive, okay? So, and we will navigate until the return, until this list is empty. And I will just got here the items that have the alcohol level above 15, okay? So really alcoholic beer, of course. And let's call this new method. I hope that I made everything working here. I believe so. So it's navigating on the return list on pages. It's using pages of return. So here I have the list of my beers. Okay, so guys, we are in the end of this session. Let me just be back to my slides to show that my last slide is to invite you to register for Red Hat Developers Program. Here we have a lot of content about Java, microservices, Kubernetes, Linux, containers, and so on. So you can scan this QR code or go to this URL. Everything free. We don't send spam, of course. We are a big company. And we also invite you to some events, especially from Dev Nation. Okay, so guys, I will now go to the Q&A room, okay, and see you there and have a great event.
Your Q&A questions are beyond support for Microsoft, for MicroProfile, sorry, what other capabilities does Quarkus provide? You can read from your chat or I can read them to you as you prefer.
Okay, no, I can read from my chat. I have it here. Let me just open my other tab. Beyond support MicroProfile, what other capabilities does Quarkus provide? Okay, Quarkus implements also a lot of Spring APIs, a lot of Camel APIs. The point of Quarkus is not to have competition between frameworks, but also to welcome the users of Jakarta, of MicroProfile, of Spring, of Camel, of Kafka, and so on. So it's not a matter of competition, but to welcome everyone. How Quarkus is different from Spring Boot? It's not different. Implements some Spring Boot APIs. What's the best way of doing? Let me refresh here. Okay, I believe that I answered.
It's what is a better way of doing serverless app without cloud?
Okay, thank you very much.
Question.
What's the better way of doing serverless app without cloud? Well, having a lot of servers, because when we think about serverless, is not having serverless, but that you're not managing the service, okay? But every company that is using serverless application, they are relying or in a big data center that they own or a data center of some vendor, okay? So it's not a matter of having or not a cloud, but having an infrastructure to hold your serverless application. Okay. So, okay, session is over. Thank you guys. Have a great event. See you. Bye-bye.